Hello, we're looking at the geometry section 10-4, talking about perimeters and areas of similar figures. This is found on page 636 of your textbook, example or problem number 1. As we look at this, we're looking for, finding the ratios of similar figures. And one of the things that we do here is, these are two trapezoids over here. One has, these are similar trapezoids. This one has a length on top of 6 and the other one has a length on top of 9. Now, when we look at those particular ones, it says the trapezoid at the right, they're similar. The ratios of the lengths of the corresponding sides are 6/9, which of course reduces to 2/3. Now, if we're looking at what is the ratio of the perimeters, the rule on the previous page tells us that the scale factor, which is comparing the two corresponding sides, which we knew reduced down to 2/3, that the perimeter follows the same way as those do. So if the scale factor is 2 to 3, then the perimeter will also be 2 to 3. So that's what it's really trying to say right here, is that the corresponding sides would be 2 to 3, so the perimeter is also going to be 2 to 3. What is the ratio of the smaller to the larger of the areas? Okay, the ratio of the areas is the square of the ratio of the corresponding sides. So because area, remember area is square units, that's square inches, squared feet, squared centimeters, squared meters, whatever that might be. Area is always in squared units. So all we have to do is we have to take the scale factor, which we just found out to be 2/3, which is again the same as the perimeter, and we're going to apply that right here. All we have to do though is square it. 2 squared of course becomes 4 and 3 squared becomes 9. So the scale factor for area, or sometimes we call it the area factor, is 4/9. Now, let's see if we understand what that's saying. Two similar polygons have corresponding sides with a ratio of 5 to 7. So that means if the sides have a ratio of 5 to 7, what is the ratio, again, the larger to the smaller? Well, the larger one's going to be 7, the smaller one's going to be a scale factor of 5 of the perimeters. And so what we're going to find is, remember, perimeters are just the same. So we're talking about 7/5. And my pen's not working correctly. Okay. So that's going to be 7/5. Now, what is the ratio larger to smaller of the areas? Well, again, going larger to smaller, we're talking about 7/5. Again, my pen is messing up. 7/5. And we're going to square each one of those. And so we're really talking about 49 to 25. Okay. And so the answer to B, comparing the larger to the smaller, would just be the square of these two ratios right here of 5 to 7. So we would end up with 49/25 as the ratio for the areas. And it's as simple as just taking the scale factor and squaring both of those scale factor terms to find the area factor. Okay, hope this was helpful.